In this problem, we took a toy flying pig and hung it from the ceiling. When we hung it from the ceiling, it extended down 0.99 meters. We then gave it an initial velocity and it went in a circle. And when measured from the ceiling, it hung down 0.76 meters. From this information, we should be able to figure out what theta is and what the radius of the circle is. To find theta, we should notice that this length from the ceiling to the pig is still 0.99 meters. And so we have a right triangle here. To get this angle, I can use sine theta equals opposite over hypotenuse. So the sine of the angle equals 0.76 meters over 0.99 meters. So theta, which is the inverse sine of 0.76 over 0.99, is equal to 50 degrees. Now to figure out this radius, which would be the same as this distance over here. I see that's another side of my right triangle, so I'll use the Pythagorean theorem. X squared plus y squared equals z squared. I'm looking for that r. The y distance is 0.76 meters, and the hypotenuse is 0.99 meters. Plugging that into my calculator, I figure out my radius is 0.63 meters. Next, I want to look at the forces acting on the pig. So when the pig is sitting over here, the string is pulling up at an angle like this. So there's our tension. And it has weight. And we should notice that this angle over here is 50 degrees. This tension has two components. One component in the y direction, I'll call that Ty, and a component in the x direction, Tx. So when I look at the sum of the forces in the y direction, they should be equal to 0, because the pig neither accelerates up nor accelerates down. So the sum of the forces in the y direction, which is Ty minus Fg, should equal 0. So to figure out the y component of the tension, we take the whole tension and multiply by the sine of 50. The weight of the pig was 0.157 kilograms times 9.8 meters per second squared. When we solve for the tension now, we can see it's 2.0 newtons. Now I'm going to look at the sum of the forces in the x direction. Here I only have the tension in the x direction, and that tension in the x direction is providing the centripetal force. Keep in mind that this pig is going in a circle, and so there must be a force pointed to the center of that circle, and it must be equal to centripetal force, which is mv squared over r. So the tension in the x is T cosine theta. We know our tension from before is 2 newtons. The angle is 50 degrees. The mass is 0.157 kilograms. And the radius was 0.63 meters. Solving for the velocity on our calculator, we get 2.3 meters per second. Now I want to figure out how much time it will take to do 10 laps. So the speed of the pig should equal to the distance around the circle, or the circumference, divided by the period. And the pig we just figured out was going at 2.3 meters per second. The radius of the circle is 0.63 meters. And we can find the period. The period turns out to be 1.7 seconds. So to do 10 laps, we have 10 periods, would be 17 seconds. And if you remember from class, it did take 17 seconds for the pig to make 10 laps around the circle.